Assalamu alaikum dear students, I am your instructor for the course Linear Algebra, and today is the 5th lecture of Linear Algebra. Let me recall what we have done in the previous lecture, which is the lecture number 4. In the previous lecture we have learned about the matrix equation, and we have done a very important result about the equivalence of the 4 different statements, logically, which are the logically equivalent statements. So matrix equation हमने सीखी थी. Matrix equation और vector equation are equivalent equations. Matrix equation का solution exist करता था if the vector equation का solution exist करता है. In fact क्या होता है कि आपका matrix equation का solution, vector equation का solution and the matrix of coefficients जो है, if the matrix of coefficient has the pivot position at every element, then these 3 statements are logically equivalent. And in fact, the space columns of the matrix A also spans a certain space. It depends upon the system of linear equations, the number of equations and number of unknowns. So the matrix equation, ये जो है ये हमने डिटेल स्टडी किया था. फिर हमने एक बड़ा important question किए थे, such that whenever we say that the given vectors from a space spans the space, हमने एग्जाम्पल किया था कि हमें 3 डिफरेंट वेक्टर्स दिए गए थे R3 स्पेस में से, और हमने ये चेक किया था कि whether the span of these 3 vectors is equals R3. These are very important questions in which we solve the system of linear equations corresponding to the taking arbitrary element of R3, and then we solve a system of linear equation and try to find out the solution of the system of linear equation. If we have the solution of the system of linear equation in which the left hand side is the linear combination of the given vectors and the right hand side is the arbitrary vector of the space. For example, हमने example की थी जिसमें R3 के लिए हमने किया था तो R3 का arbitrary element लिया था. अगर आपका ये सिस्टम ऑफ लीनियर इक्वेशन उसका सोल्यूशन एग्जिस्ट करता है, इन अदर वर्ड्स द सिस्टम ऑफ लीनियर इक्वेशन इज कंसिस्टेंट, देन वी से दैट द स्पैन ऑफ द गिवन वेक्टर्स इन फैक्ट इक्वल्स द स्पेस. एग्जांपल में वंस अगेन आई एम टेलिंग यू, एग्जांपल में माय स्पेस R3 थी. फिर एट द एंड ऑफ द लेक्चर मैंने आपको कुछ प्रैक्टिस प्रॉब्लम्स दिए थे. प्रैक्टिस प्रॉब्लम्स एज यूजुअल हर लेक्चर में स्टार्ट करता हूँ by solving some of these practice problems. So let's start the lecture, and in today's lecture what we have to do, let's find out. So today we have lecture number 5, and these are the practice problems which I am going to solve now in this lecture. There are 2 practice problems. These are simple problems. Suppose the first problem is, suppose A is a 4 by 4 matrix. We have a matrix A which is 4 by 4 matrix, and B is a vector in R4 with the property that AX equals B has a unique solution. So A is any 4 by 4 matrix, B is a vector in R4 with the property that our system of linear equation, this matrix equation represents the system of linear equation, has a unique solution. You have to explain why the columns of A must span A4. In fact, हमने last lecture में, 4th lecture में एक result किया था जो कि हमें ये बताता था कि these 2 statements that AX equals B has a solution, and the statement that the columns of A span the space RM. Previous lecture में RM थी, अब M हमारा यहाँ पे 4 है, we have R4. So these 2 statements are logically equivalent. Logical equivalent statements are those statements which are true. If one of them is true, then the other is also true. If one of them is false, the other is also false. इनफैक्ट हमने थ्योरम में 4 डिफरेंट स्टेटमेंट्स की थी जो कि लॉजिकली इक्विवेलेंट थी. सिस्टम ऑफ लीनियर इक्वेशन हैज अ सॉल्यूशन, देन द वेक्टर इक्वेशन, एक वेक्टर इक्वेशन हमने लिखी थी, वो भी उसका भी सॉल्यूशन सेम सॉल्यूशन है, उसका भी सॉल्यूशन एग्जिस्ट करेगा. कॉलम्स ऑफ A span Rn, or here in this particular example we have R4. So we have to just apply that result which we have learned in the previous lecture, that the following 4 statements are logically equivalent. So this is the explanation why the columns of the A must span R4. The second practice problem is rewrite the numerical matrix equation below in symbolic form as a vector equation. आपको ये matrix equation दी गई है. Here A is this one, X is this one, and your B is this one. So your matrix is B is this one. So your matrix equation becomes AX equals B. अब matrix equation और उसके correspond equivalent vector equation we have studied in the last lecture. ये हमने last lecture में पढ़ा था. और आपसे पूछा गया है कि symbolic vector equation जो है वो आप लिखें. अगर मैं इस वेक्टर की एंट्रीज को x1, x2, x3, x4 एंड x5 कहूं, इस कॉलम वेक्टर जो है इसको B कहूं, सो इफ आई मेक माय कॉलम्स एज A1, A2, A3, A4 and A5, then my required symbolic vector equation will be x1 A1 plus x2 A2 plus x3 A3 plus x4 A4 plus x5 A5 equals B. This matrix equation and this vector equation are equivalent, where A1 is the first column of the matrix A, A2 is the second column, A3 is the third column, so on and so forth. X1 is the first entry, X2 is the second entry, X3 is the third entry, so on and so forth up till 12th. In today's lecture, we are going to discuss homogeneous linear system. Let me give you an example of a homogeneous linear system. x1 plus 2x2 equals 0, 5x1 plus 3x2 equals 0. This is a 2 by 2 system, and this system has a particular property that the right hand side of both two equations contains 0. In other words, we have B equals null vector 0 0, जिसको null vector को हम bold 0 से denote करते हैं. So such a system in which the right hand side each equation's right hand side is 0, we call such a system homogeneous system, linear system. So this is the general definition of homogeneous linear system. A system of linear equations is said to be homogeneous if it can be written in the form AX equals 0, where A is an m into n matrix and 0 is the 0 vector or null vector of Rm. If we carefully observe that if we take x1 equals 0 and x2 equals 0, so this system of 2 by 2 equations becomes 0 equals 0 and 0 equals 0. So the homogeneous system of linear equation always has a solution which is the null vector. We call such a solution which consists of zeros of a homogeneous system, which always we have a trivial solution, because we always have that solution. Such a solution is called a trivial. Any non-zero solution is known as the non-trivial solution. So trivial and non-trivial solution, the zero solution is usually called the trivial solution. For a given equation Ax equals 0, the important question is whether there exists a non-trivial solution, that is a non-zero vector x, such that this equation is satisfied. We have a remark. The homogeneous equation Ax equals 0 has a non-trivial solution if and only if the equation has at least one free variable. If you remember that we have defined the variables as basic variable and free variables. Free variables are those variables which can take any value from the set of real numbers, and basic variables are expressed in terms of free variables, and we always have a free variable whenever we have infinite many solutions. We already decided that a system of linear equation can have a unique solution or infinite many solutions. If we have infinite many solutions, then there must be at least one free variable. कम से कम आपके पास एक free variable जरूर होना चाहिए अगर आपका system of linear equation के infinite many solutions हैं तो. अब homogeneous system of linear equation जो है इसका एक null vector तो जरूरी होता है solution. तो अगर आपका non-trivial solution exist करता है किसी homogeneous system of linear equations का, इसका मतलब है कि आपके पास एक non-zero solution है. एक नॉन जीरो सोल्यूशन होने का मतलब है कि हमने ये डिसाइड किया हुआ है कि सिस्टम ऑफ लीनियर इक्वेशंस जो होते हैं उनका या यूनिक सोल्यूशन होता है या इनफाइनाइट मैनी सोल्यूशन होते हैं. इट मींस इफ योर होमोजेनियस सिस्टम ऑफ लीनियर इक्वेशन हैज अ नॉन ट्रिवियल सोल्यूशन, इट मस्ट हैव इनफाइनाइट मैनी सोल्यूशंस. और अगर इनफाइनाइट मैनी सोल्यूशंस होंगे तो हमारा कम से कम एटलीस्ट वन फ्री वेरिएबल होगा. ये रिमार्क जो मैंने लिखा है ये इसी प्रॉपर्टी को, इसी फैक्ट को डिस्क्राइब कर रहा है. लेट्स गो टू द नेक्स्ट स्लाइड. डिटरमिन इफ द फॉलोइंग होमोजेनियस सिस्टम हैज अ नॉन ट्रिवियल सॉल्यूशन. यू आर गिवन a homogeneous system whose right hand side is 0, and we have to check whether this system has a non-zero solution or not. So we will write down the augmented matrix. Of course, the rightmost column of the augmented matrix will consist of 0, 0, 0, which correspond to the B. And here for the homogeneous system we have 0, 0, 0. And of course we will try to reduce this augmented matrix into the echelon form or reduced echelon form for getting the system. So this is the pivot element and this is first column is the pivot column. I will make these two elements -3 and 6 zeros. So in the next row I have made the row operations such that these two elements are zeros, and these row operations are that R2 plus R1 and R3 minus 2 times R1. So these two row operations will make these two entries as zeros. So we have zeros here and some other entries here. Next pivot element is this one, and I have to make all the entries below this pivot element as 0. So I will do the row operation that R3 plus 3 times R2, and I reach to this matrix. 3 pivot element and all entries are 0. If I want to get the reduced echelon form, so above the pivot element I have to make 0. So I will first make the row operation such that these elements are 1, the pivot elements are 1, so the first row operation is 1 by 3 R2. Similarly, I will make this operation as the second row operation 1 by 3 R1, and I have this reduced echelon form. Here we have 1. And if I convert this reduced echelon form to my symbols x1, x2, I have this equation. The third equation the third row give me 0 equals 0, second give me x2 equals 0, so I am having the value of x2 equals 0. And this equation, the first equation give me x1 equals 4 by 3 times x3. So I have a free variable. x3 is a free variable. So our homogeneous system of linear equation has a non-trivial solution. In fact, I can write the solution set. इस solution set को x1, x2, x3 इस solution set को मैं लिख सकता हूँ in terms of free variable x3 such that 4 by 3, this is the vector, I have to find out this vector, x2 equals 0 and x3 equals 1. x1 equals, if we equate and solve this equation, we are having x1 equals 4 by 3 x3, x2 equals 0 and x3 equals 1, which means x3 equals x3 and x3 is a free variable. Such a representation of the solution of system of homogeneous linear system we call such as representation parametric representation of the solution. We will learn this one in this lecture. And if I denote this one with a vector v, this vector, then I can write the solution as x3 into v, where v equals 4 by 3, 0 and 1. And x3 I can take any parameter. I call this one x3 variable as a parameter. So let's go to the next slide. The very simple homogeneous system of linear equation consists of only one equation with the right hand side as 0. A single linear equation can be treated as a very simple system of equations. I have to describe all solution of the homogeneous system. So from this equation I can have 10x1 equals 3x2 plus 2x3 and x1 equals 1 by 10 3x2 plus 2x3, which is further equals 3 by 10 x2 plus 1 by 5 x3. So I will try to write down, this is the simplest system of linear equation with right hand side equals 0, जिसका हमने नाम जो है homogeneous linear system रखा है. अगर इसका solution जो कि ये solution है, अब आपका x1 की values x2 और x3 की values देने से आ रही हैं. So my conclusion is that x2 and x3 are free variables. These are free variables, and if I have to write down the solution of this system into the vector form, then I will write x1, x2, x3, and I have to find out I will write my free variables plus x3. Now I have to find out these vectors such that my solution becomes this one. So x1, what is the coefficient of x2? The coefficient of x2 is 3 by 10. So the first component of this vector will be 3 by 2, 3 by 10. x2 is a free variable, so x2 equals itself, I will write 1. x3, there is no part from the x3. x3 is also a free variable, so x2 का coefficient यहाँ पे मैं 0 put करूँगा, because x3 equals, let's say, s and x2 equals t, where s and t belongs to real numbers हैं. तो आपका यहाँ पे फिर x2 जो है किसके रिप्लेस हो जाएगा? मैंने x2 को t लिया है और x3 को मैंने s लिया है. ठीक है, तो ये वेक्टर मेरा फर्स्ट वेक्टर v वेक्टर आ गया, लेट्स से v. सिमिलरली x1 इक्वेशन में 3 by 10 x2, ये कंपोनेंट मैंने x2 का इस वेक्टर से ऑब्टेन कर लिया. अब मुझे x3 का कंपोनेंट चाहिए, विच इज, अगर मैं x3 की वैल्यू s यहाँ पे डाल दूं 1 by 5, सो 1 by 5 यहाँ पे मैं लिखूंगा. ठीक है, आई हैव टू फाइंड आउट दीज वेक्टर्स सच दैट दिस इज द सॉल्यूशन ऑफ द सिस्टम ऑफ लीनियर इक्वेशन, अगर ये x1 भी इक्वेशन में लिखूं इन टर्म्स ऑफ s एंड t में, दैट विल बिकम 3/10 t प्लस 1/5 s. सो व्हाट इज द x2 का कंपोनेंट? s के इक्वल तो है नहीं, s 0 है यहाँ पे, सो आई विल पुट 0 हियर. ठीक है. x3 का कंपोनेंट, s का कंपोनेंट क्या है? 1 है, x3 इक्वल x है, तो आई विल पुट हियर 1. सो this is what we call parametric vector form of the solution of homogeneous linear system. This one, this system, x1, x2, x3 equals t 3/10 1 0 plus s 1/5 0 and 1. This is the parametric vector form. Okay, so in general parametric vector form is x, your vector x, s and t are real numbers, and u and v are some vectors. So the important thing is that whenever we have a non-trivial solution of the homogeneous system of linear equation, then we always able to write down the solution of the homogeneous system of linear equations in terms of parametric vector form, as I have written in this case. So we have a homogeneous linear system. Example is, if possible, write the non-trivial solution of the following system in parametric form. Non-trivial solution हमने इसका निकालना है और उसको parametric form में भी लिखना है. So first of all, the first step is, मैं क्या लिखूंगा? मैं इसका augmented matrix लिखूंगा system का, which is 2 1 1 -3 -3 0 and 0 0 0. So this is the augmented matrix of the homogeneous linear system given in this example. अब मैं रो ऑपरेशंस करूंगा. रो ऑपरेशंस मुझे क्या करना पड़ेंगे? r2 -2 times r1, that will make this element 0, and r3 plus r1, that will make this element 0. So I will have 1 0 0, 2 -3 0, and here I have to subtract 2 times -4. Here I will have -3, and here I will have 2 times -3 plus 6 equals 3. Here I will have 3 equals 0, and here we will have 0. Similarly, just I am adding r3 to r1, so we have 3 -3 and 0. Next, my pivot element is this one. I have to make this 0, so I will do the row operation r3 plus r2, and my matrix will become 2 -3 0 -3 3 0, as it is 0 0 0. When I transform this augmented matrix, which is in echelon form, into the equations, I have minus x1 plus 2x2 minus 3x3 equals 0, minus 3x2 plus 3x3 equals 0. From here I have x2 equals x3, and my x3 is a free variable. So we have the non-trivial solution of the system, homogeneous system, and from this equation I can have x1 equals minus 2x2 minus 3x3, and when I put x2 equals x3 from this equation, I have minus 5 x3, the value of the x1 in terms of x3. Now let's learn how to write down the parametric equation of this one. Let's say x1, x2 and x3, I have to write down the solution of this one. x3 is the free variable. So I consider x3 as a new parameter s, where s belongs to real line. So in terms of s, I am going to find out this vector. So x1 in terms of s will become, x1 will become minus 5s and x2 will become equals s. So this vector x1, the first component will be minus 5, the second component x2 equals s, so I will put 1, and x3 equals s, I will put 1. So this is the parametric vector form of the non-trivial solution of homogeneous system given here. Let's go to the next slide. Solve the homogeneous system of linear equation. This is the non-homogeneous system of linear equation. In fact, we are going to learn, or we are going to observe the relationship between the homogeneous solution of the homogeneous system of linear equation and non-homogeneous system of linear equation, whose matrix of coefficient is same. So this is the non-homogeneous system of linear equation. The augmented matrix, you can write down the augmented matrix as this one. Now this augmented matrix can be transformed into the reduced echelon form, which is this one, and if we are going to write down the reduced echelon form into the equations, we have these equations. 0 equals 0 corresponding to R3, x2 equals 2 corresponding to R2, row 2 of this augmented matrix in reduced echelon form, x1 minus 4 by 3 x3 equals minus 1. So we have once again x1 equals minus 1 plus 4 by 3 x3, and x3 is a free variable. We have a free variable. So we can write down the solution of this non-homogeneous system of linear equations into the parametric vector form. x1, x2, how I will write? x1, x2 can be written as this one. Now minus 1, 2, 0, that is a constant vector, 2 and 0, and I am writing a vector in terms of the free variable. So the first vector, how to determine this vector? The first entry of this vector will be 4 by 3, because I have x1 equals minus 1 is coming from here, plus 4 by 3 x3. x2 equals x2, and I should have 0 here because there is no x3 term in the expression of x2, and x3 equals x3. I should have 1 here and 0 here. So this is the parametric vector form of the solution of non-homogeneous system of linear equation. Now observe that in this figure, this is the solution of the homogeneous system with the same left hand side, and all entries are 0. And this is a vector which just scale to the solution of the homogeneous linear system to a quantity equals to the magnitude of this vector, and this explains the figure. Ax equals 0. This is the solution of the Ax equals 0, which is this one, and P plus TV, which is, if this is P and this is T, x3 variable is supposed to be T, and this is V, then P plus TV just the scale or translation of the solutions of the homogeneous system by adding a vector P. So this is the relationship between the solution of the non-homogeneous system, if it exists, and the solution of the homogeneous system. Let's see, and in few examples we do find out the relationship between these two systems. For example number 1, I call this one 1. We have this one and this one. This is the homogeneous equation, this is the non-homogeneous equation. So the homogeneous equation has the solution x1 equals minus 5x2 plus 3x3. If I have to write down the vector equation or parametric vector equation for this solution. So I have two free variables, x2 and x3. So I have to find out the vectors corresponding to x2 and x3. So x2 have coefficient -5 here, x1 in this equation. So I will put here, first entry will be -5. x2 equals x2, as x2 is a free variable, so I will put 1 here. Since x3 is also a free variable and we don't have the expression for the x3, so the contribution of the x2 in the x3 is 0. So I will put here 0. Similarly, I will find out the vector corresponding to the x3. So x1, the expression of x1 we have this one, and the coefficient is 3. So I will put here 3. Then x2 does not have x3. x2 जो है वो free variable है, so I will put 0 here, and for the x3 I will put 1. If you solve this vector equation, you will exactly have this solution. In fact, you will have x1 equals -5, x2 plus 3, x3, x2 equals x2, and x3 equals x3, which is the solution of the homogeneous equation, this equation. Now we want to study the relationship between the solution of this homogeneous equation and this non-homogeneous equation. This non-homogeneous equation has the solution x1 equals -2 minus 5x2 plus 3x3. If I do the same thing with the solution of this non-homogeneous equation, x1, x2, x3, that is, I have to write down the parametric equation of this solution, then I have to add first -2, 0, 0, plus x2 -5, 1, 0, plus x3, 3, 0, and 1. So this is where we have the free variable. This is the solution of the homogeneous equation. Homogeneous equation. And this is a vector, just we add a vector. So geometrically what is going on? The solution of the homogeneous equation are just translated by a vector, and we have the solution of the non-homogeneous equation. Similarly, we can do this exactly for the second example, and I am directly going to write down for the homogeneous system x1, for the second example x1, x2, and x3. That will be, in fact, these are the same examples, so we will have the same answer for these two. So we are arriving at a very important result, and what we have observed by solving the homogeneous linear system and non-homogeneous system with the same matrix of coefficient, that is, the LHS is the same, only the RHS for the homogeneous system we have the RHS as 0, 0, 0, and the non-homogeneous system of linear equation we have some non-zero entries as of the RHS of the system of linear equation. And what we have observed that the solutions of the non-homogeneous system of linear equations are just the translations of the solutions of the homogeneous system by a single vector, what we call the P. So we have the result theorem. Suppose the equation AX equals B is consistent for some given B, and let P be a solution. P उसका non-homogeneous system का solution है. Then the solution set of AX equals B, non-homogeneous system of linear equation, is the set of all vectors of the form W equals P plus VH, where VH is any solution of the homogeneous equation. And geometrically what it is represented, we have this plane, the yellow plane is the solution of the homogeneous system. If we have the non-trivial solution, then of course we will have infinite many solutions. So, and the plane, blue plane, is the solution of the non-homogeneous linear system, and you can say that it is just translated this plane by a vector p. A vector p. It's just a translation. So if a non-homogeneous system of linear equation has a unique solution, then our homogeneous system will have zero solution. If our non-homogeneous system of linear equation has infinite many solutions, that is, infinite many solutions is a one possibility, then there is a relationship between the solution of the homogeneous equation and non-homogeneous equation, and that is just the scaling of the solutions of the homogeneous equation. Then I have written a remark: the above result apply only to an equation ax equals b that has at least one solution. Of course, if the system is inconsistent, then there is no relationship between the solutions of the homogeneous system and the non-homogeneous system. How to write down the solution of a homogeneous or non-homogeneous system of linear equations? What are the steps? If the system is consistent, writing a solution set of a consistent system in parametric vector form. So we are going to learn the steps. Row reduce the augmented matrix to reduced echelon form. This is the first step. We will write down the augmented matrix and we will row reduce that matrix to the echelon form. Express each basic variable in terms of any free variables appearing in the equation. यही exactly चीज थी जो हम पिछली examples में करते हैं. Write a typical solution x as a vector whose entries depend on the free variable if any. If there is any variable, we will write down the solution set of the non-homogeneous system of linear equation as a multiples of the free variables and some vectors. वो vectors जो हैं मैंने आपको सिखाए हैं previous examples में, और next example भी हम करेंगे जिसमें vectors हमने निकालने होंगे. Decompose x into linear combination of vectors with numeric entries using the free variables as parameter. Free variables को as a parameters हम करेंगे और free variables के correspond हम decompose कर देंगे solution को a vector plus free variables के correspond parameters and some vectors multiplied by the free variables. Let's do the. So at the end, we are at the end of our lecture, which is the lecture number 5, and we have learned how to find out the solution of the homogeneous system. In fact, we have identified or coined a term of homogeneous system of linear equation, जिसमें आपका राइट हैंड साइड जो है वो 0 0 0 पे कंसिस्ट करता है. ईच इक्वेशन जो होती है उसका राइट हैंड साइड जो है 0 होती है एंट्री. और उसके बाद फिर हमने क्या किया, हमने ट्रिवियल सॉल्यूशन डिफाइन किया, नॉन ट्रिवियल सॉल्यूशन डिफाइन किया होमोजेनियस सिस्टम ऑफ लीनियर इक्वेशंस का. उसके बाद फिर हमने होमोजेनियस सिस्टम लीनियर सिस्टम अगर है उसके नॉन ट्रिवियल सॉल्यूशन को हमने सीखा कि उसको नॉन ट्रिवियल सॉल्यूशन जो है वो क्या होता है, नॉन जीरो सॉल्यूशन. नॉन जीरो सॉल्यूशन को हमने वेक्टर फॉर्म में लिखने का प्रैक्टिस की, कुछ एग्जांपल्स की जिसमें हमने पैरामीट्रिक फॉर्म जो है सॉल्यूशन की डिटरमिन की. उसके बाद हमने वी हैव लर्न द रिलेशनशिप बिटवीन द नॉन होमोजेनियस सिस्टम, solution of the non-homogeneous system and solution of the homogeneous system. और ये different examples से हमने दोनों के दरमियान relationship जो है exist अगर करता है solution non-homogeneous system का, तो हमने वो study किया. In fact, अगर आपका non-homogeneous system of linear equation का solution exist करता है, तो there is a relationship. That relationship is correspond to the scaling the solutions of the homogeneous system. Homogeneous system के solutions को हम scale करते हैं by a vector, और ये हमने geometrically भी देखा है. So At the end of the lecture, as usual, I gave you some practice problem. In this slide, we have written some practice problems and I will give you some hint कि इन practice problems को जो है हमने solve किस तरह करना है. So the first question is, पहला question जो है इसमें if possible, write down the non-trivial solution of the following system. ये आपको सिस्टम दिया गया और इस सिस्टम के कोरस्पोंड अगर आपका नॉन ट्रिवियल सॉल्यूशन एग्जिस्ट करता है तो उसको आपने पैरामीट्रिक इक्वेशन में लिखनी है. पैरामीट्रिक इक्वेशन क्या थी वो मैंने आपको बता दी कि x को वेक्टर x को सम वेक्टर फ्री वेरिएबल्स s, let's say sf, free variable, I don't know, you have to solve it and check whether there is only one solution 0 0 0 which is the trivial solution or non-trivial solution. अगर non-trivial solution होगा तो उसको पैरामीट्रिक फॉर्म में लिखनी है. पैरामीट्रिक फॉर्म क्या होती है? s into v plus t into some other vector u. और s और t जो हैं ये रियल नंबर्स हैं and v and u are the vectors. So अगर आपका नॉन ट्रिवियल सोल्यूशन आता है तो आपने पैरामीट्रिक फॉर्म सोल्यूशन की भी लिखनी है जो कि इस फॉर्म में होती है और हमने कुछ एग्जांपल्स की हैं जिसमें हमने पैरामीट्रिक फॉर्म जो है सॉल्यूशंस की निकाली. द सेकंड क्वेश्चन इज यूज द रिलेशनशिप between the solution of non-homogeneous system of linear equations and homogeneous linear system to find the solution to the linear system this one. अब ऑब्जर्व करें कि इस लीनियर सिस्टम और इस लीनियर सिस्टम में डिफरेंस क्या है. वी हैव द सेम लेफ्ट हैंड साइड. इन अदर वर्ड्स वी हैव द सेम matrix of coefficients for the homogeneous system in question 1 and for the non-homogeneous system in question 2. Difference is homogeneous system में हमारा right hand side all zeros थे, यहाँ पे हमारा non zeros होंगे. ठीक है. तो अगर आपका इस non-homogeneous system का solution exist करता है, so ज्योमेट्रिकली हमने देख लिया है कि रिलेशनशिप क्या होगा कि आपका सॉल्यूशन इस नॉन होमोजेनियस वेक्टर का सम वेक्टर p प्लस v ऑफ h, यही हमने रिजल्ट पढ़ा, वेयर v ऑफ h इज द सॉल्यूशन ऑफ द होमोजेनियस सिस्टम और होमोजेनियस सिस्टम आपका ये सारा पड़ा होगा. ठीक है. p एक कोई फिक्स्ड वेक्टर होगा, ये आपने डिटरमिन करना है. तो आप इस सिस्टम को सॉल्व करेंगे और इसका ऑगमेंटेड मैट्रिक्स लिखेंगे. ऑगमेंटेड मैट्रिक्स लिखने के बाद आप इसको एचिलॉन फॉर्म में कन्वर्ट करेंगे. एचिलॉन फॉर्म में कन्वर्ट करने के बाद आप इसका सॉल्यूशन, इफ देयर आर फ्री वेरिएबल्स, तो आप इसका सॉल्यूशन इनटू फ्री वेरिएबल्स में लिखेंगे और आइडेंटिफाई करेंगे कि आपका, अब जब पैरामीट्रिक वेक्टर फॉर्म में आप सॉल्यूशन को लिखते हैं इस फॉर्म में, तो आपका फिक्स्ड वेक्टर p कौन सा है और आपका होमोजेनियस सिस्टम का सॉल्यूशन जो है वो क्या बनता है. ये बड़ी इंटरेस्टिंग एक्सरसाइज है. नेक्स्ट क्वेश्चन इज डिस्क्राइब ऑल द सॉल्यूशंस ऑफ होमोजेनियस लीनियर सिस्टम ax equals 0 in parametric vector form where a is equivalent to the following matrix. होमोजेनियस लीनियर सिस्टम है, a इक्विवेलेंट है इस फॉलोइंग मैट्रिक्स के, तो इसको आपने सॉल्यूशन पैरामीट्रिक फॉर्म में लिखना है. अब हाउ मेनी वेरिएबल्स वी हैव? 1 2 3 4 5 6 and this row, the fourth row give me 0 equals 0. The fifth row give me x6 equals 0. The second row give me x4 in terms of minus 4 times x5 plus 6 times x6. फर्स्ट इक्वेशन जो है ये मुझे देती है x1 equals 2 times x2 plus 3 times x3 -6 टाइम्स x4 प्लस -5 टाइम्स x5, और ये आपका यहाँ पे आके प्लस होगा इक्वेशन के दूसरी तरफ, और ये आपका here you will have माइनस एंड ये here you will have माइनस. सो दिस मैट्रिक्स गिव्स मी दिस सिस्टम. अब यहां से x4 की वैल्यू मैं इसमें डाल सकता हूं, तो मेरे फ्री वेरिएबल्स कौन से हैं? x5 फ्री वेरिएबल है, x6 0 था, ये तो एलिमिनेट हो जाएगा, x5, x2 एंड x3 फ्री वेरिएबल हैं. तो आपने पैरामीट्रिक इक्वेशन x1, x2, x3, x4, x5 एंड x6 इसको पैरामीट्रिक इक्वेशन लिखनी है सॉल्यूशन की, होमोजेनियस सिस्टम की, और फ्री वेरिएबल्स की टर्म में, यानी कि x2 वेक्टर आपने निकालना है, सिमिलरली प्लस x3 वेक्टर आपने निकालना है, ये वेक्टर क्या होगा, प्लस x5 आपने यहाँ पे वेक्टर निकालना. यही 3 फ्री वेरिएबल्स थे, x2, x3 एंड x5, क्योंकि x4 की वैल्यू यहाँ से आप डाल देंगे. आई होप कि आप ये पैरामीट्रिक इक्वेशन जो है वेक्टर इक्वेशन, पैरामीट्रिक वेक्टर इक्वेशन फॉर द सॉल्यूशन ऑफ होमोजेनियस सिस्टम, you will be able to find out this one. The last question is, does the equation ax equals 0 have a non-trivial solution, and does the equation ax equals b have at least one solution for every possible b if A is a 3 by 3 matrix with 3 pivot position. ये बड़ा इंटरेस्टिंग कॉन्सेप्चुअल क्वेश्चन है. इसके बारे में मैं आपको कुछ एक्सप्लेन कर देता हूं, एंड यू हैव टू फाइंड आउट द सॉल्यूशन ऑफ दिस क्वेश्चन. अब ये कह रहा है कि ax equals 0 have a non trivial solution. इसका नॉन ट्रिवियल सोल्यूशन है, इसका मतलब है there will be free variable. And does the equation ax equals b have at least one solution for every possible b if A is a 3 by 3 matrix with 3 pivot positions? अब हमने एक रिजल्ट पढ़ा हुआ है, इनफैक्ट लॉजिकली इक्विवेलेंट स्टेटमेंट्स पढ़ी थी, कि ax equals b, ax equals b for every b has a solution if, and the second statement was that the matrix of coefficient, जो कि यहाँ पे इस सिस्टम का matrix of coefficient है, has a pivot position at every element. आपने वो रिजल्ट जो है, जो हमने स्टडी किया था, जिसमें 4 equivalent statements थी कि matrix equation has a solution, then the vector equation for every b has a solution, then the spanning of the columns of the matrix of coefficients A, and there was a fourth statement which relates the pivot position of the matrix of coefficient for a given matrix, जो कि matrix of coefficient system of linear equation का मान. आपने वो रिजल्ट जो है वो यूज करके इस कंसेप्चुअल क्वेश्चंस का लास्ट क्वेश्चन जो है इसका आंसर करना है. ठीक है, आई होप दैट यू विल बी एबल टू डू दीज questions by yourself. As usual, in the next lecture I will solve one of these practice problems. Hopefully ये जो last conceptual question है, इसी के बारे में आपको मैं detailed solution जो है इसका explain करूँगा at the beginning of my next lecture. So we are at the end of our lecture and hope to see you in the next lecture. Allah Hafiz.